Thank you, Pierce, for the introduction. Thank you, Martin, for the invitation. So today we're going to talk about chatbots in the retina clinic. Will we soon be replaced? Let's go back and talk about chatbots. So chatbots are computer programs that simulate human conversation. And chatbots have come a long way. Some of you may remember rule-based chatbots that were in applications like MSN Messenger. But today, when we talk about chatbots, we're referring to AI-based chatbots like ChatGPT, Gemini, Claude. AI-based chatbots are fundamentally large language models, LLMs. LLMs are novel AI models designed to understand and generate human language. So those AI-based chatbots, what makes them surprising, what makes them engaging, is their ability to hold multi-turn conversations, understand complex queries, generate creative content, and adapt their tone and their style to the user intention. So how are those chatbots even built? And I think it's important, again, to take a step back to know what they're capable of. Let's take an example. Heraclitus once said, "The only constant in life is change." That sentence is broken into tokens, which are words or parts of words. One of the token is masked, such as the word change. Then you train a type of model called a transformer model to predict the word change. This is repeated until the correct word is predicted. This is repeated billions and billions of times. The way major companies train LLMs is that they take the collective written corpora of humanity and they train transformer models. This comes from all of the internet, encyclopedias, all the books ever written. The problem, however, is that our collective written corpora is riddled with misinformation and bias. So before LLMs are made public, LLMs must be aligned to our values. And collectively, we agree that our values are that LLMs must be helpful, honest, and harmless. And the way LLMs are made helpful, honest, and harmless is through reinforcement learning. So an LLM generates an output, an answer. That output is evaluated, whether given a positive or a negative grade. And then those answers help train a reward model where you change the settings of the LLM, and then it's made public. So what are LLMs capable of? A lot of people have looked at that in medicine, in ophthalmology. Our team has looked at that very early on in 2022, 2023. So we licensed a question set from the American Academy of Ophthalmology, and we tested different versions of GPT on multiple choice examinations. What is surprising is the progress. So in 2023, GPT 3.5 had only scored 55.8% on that data set. GPT-4, 75.8%. And just recently, a couple of weeks ago, when we tested GPT-5, the score was 96.5%. This goes and tells you that LLMs have the knowledge to be able to be helpful in possibly in routine clinical practice. How can you use them in clinic? I like to think of the applications in two groups: workflow improvement and clinical assistance. An example of workflow improvement is helping you with electronic health record documentation. So imagine a multimodal model that listens to your conversation with the patient, is able to transcribe and understand who's talking, write a clinical note in the EHR, and write a simplified patient summary. So this way you can focus on looking at the patient in the eye, listening to their concerns, and answering them instead of typing on the computer. Imagine a triage agent that's available 24 hours a day, 7 days a week. Patient sends a photo. They had an injection 3 days ago. Eye is red and painful. The LLM asks an important question. If the vision's affected, it is affected. The patient is correctly oriented to the emergency room. So how can you practically benefit of those? And I'm sure you've seen a lot of people talk about this online, a lot of people present about this, but how can you actually build tools that you can use tomorrow? I like to think of the ChatGPT revolution and take lessons learned from the personal computer revolution. So When people started having Macs and PCs in their living rooms, people started coming up with solutions to problems that no one had thought of, because they are domain experts. So you are domain experts, you are experts in retina. So you can come up with solutions to problems that engineers at OpenAI and Google can never think of. And how can you do that? Remember this term, vibe coding. So LLM chatbots enable what's called vibe coding. Vibe coding is a novel software approach where you can code using spoken language. You can use English to build software applications. So a retina specialist without coding expertise will prompt an AI-based chatbot, routinely referred to as agents, in English, and that model will turn the intention and the prompt of the user into code which will power a software. I'll give you an example. So let's build that triage chatbot for your retina practice. I prompt the model in English. Build a chatbot that uses large language models to triage patients for my retina practice. Within minutes, the chatbot returns a proposal with features and gives me a visual preview. It is as if you have a software developer on demand on your phone that's able to answer within minutes and costs very little. Once I approve and ask it to develop the app, we iterate. So we chat with the agent, go back and forth about features we want to add, things we want to remove, and when we're happy, and along the way, we can preview, deploy, and start using the tool. Of course, there are regulatory limitations, but you can really build things, and if the stakes are low, I don't see a problem with building tools through vibe coding. So here, I built this for this presentation. You have an AI assistant that's able to chat with the patient. The back end is ChatGPT. You can ask the patient information, age, gender, phone number, call them back if there's a problem. Vibe coding for clinicians has been studied. Ariel and David from Pierce's group have tested this in a research setting. So it took 8 clinicians without coding expertise. They asked them to build 3 apps, a habit tracker app, an image segmentation app, and a medical education app. The code was evaluated, and then they asked the clinicians about their experience. The paper has a lot of aspects, but one important takeaway is that the clinicians thought that vibe coding lowered the technical and psychological barriers to learning how to code and allowed them to rapidly develop functional prototype apps. There were some technical limitations, but I suspect that those limitations will decrease as the quality of vibe coding platforms improve. So, will we soon be replaced? No, chatbots won't replace retina specialists, but I have no doubt that retina specialists who use chatbots or AI in general will surpass those who don't. So stop waiting and start building. Your medical knowledge makes you the expert. Thank you.
Could I just before Martin introduces the next speaker, can I just ask,